this is the same thing as this. It's straight chained. And by that I just mean that we have carbon after carbon after carbon. So we get a carbon bonded to a carbon, 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 bonded to a carbon. Okay. The only difference is I bent this up and I made it look complicated. In other words, I took my molecule and I went boop, 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 boop. Okay, this is the same thing as if it was this. Okay, it's the same thing. Okay, it's still just 7 carbons in a row. Bending it up doesn't change it. Okay, so this is just still a 7 normal heptane, 7 carbons in a row. All right, so you got to understand that the very first thing you're going to do is you're going to have to go find that long carbon chain. All right, and you have to understand that bending it does not change it. Good. So let's talk about our second homologous series. Let's write this. These are the same. All right, so our second homologous series that we're going to talk about are the alkenes. These are also called the olefin series. And these are hydrocarbons with double bonds. Okay, so these are going to have double bonds. If they have double bonds, that means they are unsaturated hydrocarbons. Unsaturated. Right, so if it's a saturated hydrocarbons, all single bonds. If it's unsaturated, it means it's going to have a double or a triple bond in it. All right. These all end in -ene. Okay. They end in -ene, and you must have a number in the name to indicate where the double bonds are in the molecule. All right, so if we have double bonds, we have to tell where they are. The general formula of this group is C to the N, H to the 2N. And again, N is the number of carbons. So we can come up with our molecular formula with this guy. Alright, so let's look at one. Oops. And I want to look at this one. Nope, not this one. Sorry. This one. So this is an example of an alkene. Okay, so I have a 5 carbon chain, but I have a double bond here. Okay, so here's a double bond. Right, so this is an example of an alkene. So what I want to do is I want to draw the structural formula just like this. Right, so it's 5 carbons in a row. 1, 2, 3, 4, 5, and in this case the double bond is right there. Okay, so there's my backbone. Right, now this is where it's important that you count when you put in your hydrogens. Okay, so let's go ahead and put them in. All right, because if you don't count, people are going to do this. All right, ready? People are going to say, oh, I got to put my hydrogens in. Done. Bam. And I see that all the time. All right, And it takes me about 3 seconds to know that you're not counting, because I can look straight at this guy right here and say, hey, how many bonds are around this carbon? 1, 2, 3, 4, 5. Carbon cannot make 5 bonds. It's impossible. Same thing here. You would have 1, 2, 3, 4, 5. Nope. Nope. Okay. You can't do it that way. All right, so let's go back. 1, 2, 3, 4, 5. All right, so to put in your hydrogens, you have to count. All right, so this one has 1 bond, so it needs 3. This one has 2, so it needs 2. This one has 3. It's got a double and a single, so it only needs 1. It doesn't matter if you go up or down. Okay. This one has 3. It needs 1. It doesn't matter if you go up or down. Now, traditionally, if this one comes down, this one's going to come up, but it doesn't have to. All right, and then this one has 1, so it would have 3. So this, okay, this is your structural formula. Now, my molecular formula better match it. Better match it. Okay. C to the N, H to the 2N. Well, we know we have 5 carbons, so that means we better have 10 hydrogens. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So we're good. Okay. Now, condensed structural formula. Again, you just start at the end, and we'd have CH3, CH2, CH this time, because there's only 1 hydrogen coming off of it, CH this time, and then CH3. So there's my condensed structural formula. Now, we want to name this. Okay, we want to name it. So, we know that it's a 5 carbon chain, so our prefix for 5 is pent. It has a double bond. Okay, so this would be pentene. But as soon as I have ene, okay, that means I have a double bond, and I need to say where it is. Right, so that means I'm going to have to number this backbone. Okay, and there are 2 ways that I could number the backbone. I could number it left to right. I could number this carbon 1, this carbon 2, this one 3, this one 4, this one 5. So I could go left to right. Or I could number it in the other direction. I could say this one's 1, this one's 2, this one's 3, this one's 4, and this one's 5. Or I could go right to left. Okay. So the question is, which way do you number it? Well, to number the backbone, so to number our backbone, the double bond must come from the lowest possible carbon. Now, what do I mean by that? Well, let's look. If I number it left to right, the double bond is coming from the 3rd carbon. It's between 3 and 4, so it comes from the 3rd, goes to the 4th. So this would be coming off the 3rd carbon. But if I go right to left, it's coming off the 2nd carbon. Okay, if I go right to left. So this way is the correct way to number it. Okay, so if we look at this, I could number it 1, 2, 3, 4, 5, and the double bond would be coming off the 3rd carbon. Or I could number it 1, 2, 3, 4, 5, and it would be coming off the 2nd carbon. Right? It needs to come off the smallest carbon. Right? So it should be coming off the 2. Right? Now, if I flip it this way, if I just flip it over, now I would number it 1, 2, 3, 4, 5. So it's still coming off the 2 carbon. All right? What this does, all right, it just orients our molecule for us. All right? So we just have to decide, are we going to go left to right or right to left? And the double bond is going to dictate which way we number. So this molecule right here would be 2-pentene. and the 2 is where the double bond is. It tells me it's coming off the second carbon. All right. Let's try another one. Let's say that we have, how do I want to do this? Oh, let's say we have this. Let's say I give you this condensed structural formula of CH3, C3H7, CH, C3H7. And I want the molecular formula, the structural formula, and the name. Well, the first thing I would do, right, is I would come up with the structural formula. Right? So remember what this means. It really means this. It means 3 carbons in a row with our 7 hydrogens. Okay, so we got 1, 2, 3, and we got 1, 2, 3, 4, 5, 6, 7. That's what this means. All right, and then we have a carbon with 1 hydrogen, and then we have another carbon with 1 hydrogen. All right, I can't put any more hydrogens on that, so that tells me that there has to be a double bond there. And then I got 3 carbons in a row with our hydrogens again. So this would be my structural formula. Okay. So now here's my backbone, nice and straight. I got 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row. So this would be C8, H16. So I better have 16 hydrogens around that. Let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I do. Okay. All right, let's name this. Well, an 8 carbon chain is oct. It's got a double bond, so it's octene. All right, now I need to number it because I need a number. I have to know where the double bond is. So I could number it 1, 2, 3, 4, 5, 6, 7, 8. Or I could number it 1, 2, 3, 4, 5, 6, 7, 8. If I go left to right, it's coming off the 4 and going to the 5. If I go right to left, it's coming off the 4 and going to the 5. Okay, now I did this one on purpose because does it matter which way we number it? And the answer is no, because it's smack dab in the middle of the molecule. All right, so it's always, no matter which way you go, it's coming off the 4 carbons. So this would be 4 octene. All right, well, what if we have more than one double bond? So these are alkenes with 2 or more double bonds. Well, if we have 2 double bonds, we're going to use, instead of just ene, we're going to use diene. And 2 numbers, one for each bond. If there are 3 double bonds, we're going to use triene. And 3 numbers. If there are 4 double bonds, we're going to use tetraene. And 4 numbers. For our purposes, we'll never go above this. Okay, you'll never have more than 4. All right, so let's look at a structure like this. Okay, so I got a 1, 2, 3, 4, 5 carbon chain, okay, with 2 double bonds. Let's go ahead and put in our hydrogens because you got to count. Okay, so this one already has 2 bonds, so this is going to come off at an angle. All right. This one already has 4, so it has no hydrogens. This one has 3, so it's going to have 1. This one has 2, so it needs 2, and then this one needs 3. Okay, so there would be my structural formula. Let's go ahead and name this. Okay. So this is a 5-carbon chain. All right. So it's a type of pent. All right. There are 2 double bonds. So instead of just pentene, it's a diene. Okay. But when you have, if you have a, so it starts with a, it doesn't start with a vowel. We end up adding an A in here. So this becomes pentadiene. Pentadiene. Right. Now, so this is telling me 2. This is telling me double bonds. I need 2 numbers then in front of this, telling me where the double bonds are. Well, I got to number the backbone, so I could number it 1, 2, 3, 4, 5, or I could number it 1, 2, 3, 4, 5. Okay, left to right, they come off the lowest carbons. Right, so this would be 1, comma, 2, pentadiene. All right. Go ahead and name this. Well, we got 1, 2, 3, 4, 5, 6, 7 carbons in a row. So that's a type of hept. We have 3 triple bonds. So that's going to be a triene. But instead of hept tri, we're going to use hepta. Triene. Okay. If I have a tri, that means I need 3 numbers. Okay, a number for each one of the triple bonds. All right, so how am I going to number it? Left to right or right to left? Well, if I go left to right, it's 1, 2, 3, 4, 5, 6, 7. Right? And I got this thing coming off of a 6, or I could go 1, 2, 3, 4, 5, 6, 7. So then I would have one coming off the 1, coming off the 3, coming off the 5. So we would number this right to left. So this would be 1, comma, 3, comma, 5, heptatriene. Alright, so let's deal with our last homologous series, and then we'll call it a day. And now that we've done alkenes, the last series is just like this. And these are called the Alkynes. And this is sometimes called the acetylene series. Maybe you've heard of acetylene torches. Okay, they'll burn underwater. Okay, but very hot. And these are hydrocarbons with triple bonds. Again, these are unsaturated. Unsaturated. These end in YNE and a number for the triple bond. And our general formula for this group is C to the n, H to the 2n minus 2. All right, so let's go ahead and name this guy. Now, this thing is really just a straight chain. I bent it up, all right, and I did it on purpose just to make it complicated. All right, in reality, does it look like this? No, it doesn't look like this, okay? It doesn't look like this, all right? Matter of fact, okay, it wouldn't look like it if it was straight chained either, all right? So this is just 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row. It's the same thing as this. 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row. Triple bond is here, and these are all single bonds. Let me put these guys in. These two things are the same thing. Bending it doesn't change it. Okay, it's still just a straight chain. All right. So we got 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 carbons in a row. All right, which is an oct. We have 1 double bond, so this is an octine. Now I got to number this backbone. Okay, I could go 1, 2, 3, 4, 5, 6, 7, 8, and it would be coming off the 5. Or I could go 1, 2, 3, 4, 5, 6, 7, 8, and then it would be coming off the 3. And again, just like the alkane or alkenes, you want to number it so it has the lowest possible carbon. So this is coming off the 3rd carbon, so this would be 3-octene. All right. Well, what if we have more than one triple bond? All right. It's the same rules as the alkene. So let's say that we have something like this. I'm going to go put in my hydrogens now. So this guy has 3 already, so he only needs 1. He's got 4, he doesn't need any. He's got 2, so he needs 2. He's got 4, he doesn't need any. He's got 4, he doesn't need any. He's got 4, he doesn't need any. This guy needs, whoa, what did I do here? This isn't right. That bond shouldn't be there. Triple bond there. So he doesn't need any. He needs 2, he needs 3. Okay, all right. So let's go ahead and name this guy. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in a row. All right, so 9 is known. And this is going to be an ine. Okay, but I have 1, 2, 3, 3 double bonds, so it's a tri-ine, a known a trianine. We put an A in there. All right. I need 3 numbers. Okay, so again, which way would I number it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be coming off the 1, the 4, and the 6. Okay, so this would be 1, 4, 6. known a triine. Alright. Alright, so that's what we're going to stop for. Actually, let me show it to you real quick. Not that, but I do want to show you this with a triple bond in it. So this is an example of, this would be an example of an alkyne. So this is where our triple bond is. Okay, and it does change our structures. Okay, definitely changes our structure quite a bit. Right, so you can have multiple triple bonds. Right. Okay, so that's where we're going to stop for today. Next class we'll pick up with isomers and we'll start getting into our functional groups and branched hydrocarbons. Alright, so have a good one and we'll see you soon.